Any object which has mass has a gravitational field around it. If another object with mass and therefore a gravitational field is nearby, these objects' field will interact with each other. The force as a result of this is called gravity. This force is proportional to the product of the masses but inversely proportional to the square of the distances separating the centers of mass. F is proportional to m1 multiplied by m2 on distance squared. In order to turn this proportional relationship into an actual equation, a gravitational constant g is introduced, acting as the constant of proportionality. F is equal to g m1 multiplied by m2 on distance squared. Weight is the force acting on an object with mass due to gravity. This force can be calculated with the above equation, but on Earth you can use the shortcut F equals mg. G here is 9.8 meters per second squared, which accounts for Earth's mass and radius and gravitational constant. We often perceive weight to be the force reacting against the weight force. Standing on the ground, a person has a weight force but also has a normal reaction force to counteract this, as the person is in equilibrium. If we took away this normal reaction force and instead had him in free fall, he would experience apparent weightlessness, even though the weight force is still acting on him. In order to move a massive object away from another massive object, work must be done, and that object gains energy. The energy the object gains is related to its position, and is called gravitational potential energy. If there is no impediment to movement, the object will readily convert gravitational potential energy into kinetic energy as it falls towards the other object. We usually say that if an object is on the ground, it has no gravitational potential energy, as it can't fall to convert any energy to kinetic energy. This is not a thorough definition, as Earth's altitude changes from location to location, and so the 0 point is not consistent. Instead, an infinitely far distance is chosen as the 0 point. The further you get from an object, the less of a force due to gravity you experience. After an infinite distance, it's acceptable to say that you have no force and thus no gravitational potential energy. This means the gravitational energy of any object must be negative, as its energy must be increased in order to move it an infinitely far distance to 0. If an object on Earth has, say, negative 150 kilojoules of gravitational potential energy, then this means that descended to an infinitely far distance, to completely escape Earth's gravitational field, 150 kilojoules of work must be done on this object. If you wanted to move an object from an infinitely far distance to Earth, negative work must be done on this object. Work is equal to force times distance, and the gravitational force is equal to g m1 m2 over d squared. Substituting this in for F will give us our energy potential, and is equal to g m1 m2 on d. A negative sign is added, as this value is always negative.